Homework 3.1, Quadratic Functions, Video 8. Homework due 11:59 p.m. on Wednesday, May 27th, 2020. This final video is associated with, or correlates with questions 15 and 17 and homework 3.1. In the previous video, we had some fence. We built a rectangular pen to get the biggest area. It ended up being a square. Another bonus question, listen closely. In the previous video, there was specifically 100 feet of fencing, and the rectangle that gave us the biggest area ended up being a square. The bonus is to prove that it will always be a square, no matter how many feet of fencing it is. Now, how do you approach that problem? How do you make it more generic? The same way you make any problem more generic. You take out the specific number and replace it with a variable. So to prove that a square will always give you the biggest area no matter how many feet of fence you have to change the 100 in the previous problem to something generic. I wouldn't call it f because that looks like a function. You can call it anything you want. Call it k. What if I had k feet of fencing instead of 100 feet of fencing? See if you can replicate the process and prove at the end the dimensions match and it's a square. Yeah, that's a neat bonus. But in this problem, it's a little bit different. We're still building a pen. This time we have 40 feet of fencing, but we're going to build it up against the side of a barn. And the part against the barn does not require any fence. So what dimensions yield the maximum area? Now, in the last video, I kind of told you this one would be a little bit easier. I'll tell you why in a moment. But let's start by sketching a pen up against the side of the barn and realizing we don't need extra fence over here. To attack a problem like this, you have to represent what you're looking for with a variable. Now, I have a couple of dimensions here. I have this length, if you will, that's one side, and I have this width that's two sides. Because this side is used twice, I think that's where I'll call it x. And that other one would be x. But if we had 40 feet of fencing, do you know what we could write for this? Think about it. Think about it if we had a specific number, like for example, let's say this was 12 and 12. How could you figure out what's left? Well, add the two 12s and subtract them from 40. So do the same thing here. Add the two x's and subtract it from 40. So if we decided to put an x here, that would force an x over there, and this would have to be 40 minus 2x. And if you check by adding all of these, all the x's would cancel, and it would leave you with the 40 feet of fencing. So why is this problem easier than the previous one? Because in this problem, and in number 17, the picture is already drawn and labeled for you. So the hardest part of the problem, in my opinion, is already done for you. We still have to set up a function to represent the area. And area is just length times width. So length, we'll call it x, and width, 40 minus 2x. That'll give us the area of that pen up against the barn. Now this is going to run the exact same course as the previous problem. If we distribute our function a of x is 40x minus 2x squared, we don't have to put it in standard form, but general form. But let's do it by writing the negative 2x squared first, and then the plus 40x second. So we can say the exact same things we said in the previous video. This is the function's graph is a parabola. It opens downward because the leading coefficient is negative. I know that this looks something like that. I am looking for the maximum area. And because of this vertex, whatever the x is, and whatever the value that comes out of the function is, at the vertex, that will be the biggest possible area we can get. And this will tell us one of the dimensions that will achieve it for us. So, how do we find it? The same way we find a vertex anytime, when your function is in general form. The formula for the x-coordinate is negative b over 2a. Well, the b is 40, and so stick a negative on it. The a is negative 2, so double it to get negative 4. Negative 40 divided by negative 4 is 10. And right away I know that this vertex is going to be at 10 comma something. And I now know this dimension, which means I can now calculate this one. But let's finish finding the vertex. Remember, to find the y-coordinate, or in this case, the area coordinate, you just substitute the x into the function. So if we put 10 into the function, we get negative 2 times 10 squared plus 40 times 10. Again, tread lightly over here, exponents before multiplication. 10 squared is 100. 100 times negative 2 is negative 200. Plus 40 times 10 is 400. And that sum is 200. And that's not the other dimension. How can one dimension of a rectangle be 200 when you only have 40 feet of fence? But that dimension represents the maximum area. If the question asks you the maximum area, and it does, then you would say it's 200. But it also asks the dimensions. One of the dimensions we labeled with x, and we already found it, it's x equals 10. But the other dimension was labeled 40 minus 2x, so we got to work that out. 40 minus 2 times 10, so 40 minus 20, which is 20. So this is a 10 foot by 20 foot pen. And because two of the sides are 10 and one of them is 20, it does add up to 40. And their product is 200, which is the maximum area, and it's the largest area we're going to get. I've got a bonus so crazy, I don't even know if I should put it out there. I've already put out 2 bonuses in this video series. And by the way, if I put out multiple bonuses, you're welcome to answer as many as you can, but let's just say I'll give you credit for 2 of them because it wouldn't be fair to give you a bunch of bonus points on one test. But, so here's my bonus question. And I'm trying to figure out what to bribe you with, not just 5 points on a test. I think this one's worth more than that somehow. I know. If you get this bonus question, I will not only add 5 points to this test, I will go back and add it to a previous test as well. So it's worth 10 points, 5 on this test, 5 on an old test. So here's the bonus question. When it was a regular rectangle, it was a square to get the biggest area. The big bonus question here is, can you generalize this? In other words, can you tell me the relationship, or what type of shape you should get in this scenario where one of the sides is missing because it's up against the barn? Here it was 10 on these 2 sides and 20 on the other. But for this bonus, you have to kind of guess. It's not really a guess. The bonus is to do this problem generically. In other words, replace the 40 with whatever. K if you want to, or any other variable. Don't use X unless you use something else here. But the big bonus is, what's the shortcut? The shortcut when it's just a pen is it's a square. Well, what's the shortcut for determining the sides here when you have this scenario? In other words, for example, if this were, and I'm just going to throw a number out here, 256, I already know what the dimensions would be. This would be 128 and this would be 64. And that would be 64. So I challenge you to try to do this problem generically and tell me in your own words how to take the fencing and divvy it up to make a pen of maximum area based on the number of feet of fencing. You'd be surprised if you can pull it off. Frankly, I'll be surprised because I'm not telling you what the answer is, but give it a try. All right, so that's the end of this video series. And if you have any questions, you know how to get a hold of me.